Carl Zakarian here with NetFocus Technologies. In this video, we will leverage Tessabyte Throughput Test application to establish a PC-to-server network throughput baseline, evaluate firewall processing throughput with TCP and security, and validate our traffic shaping policies to ensure precise bitrate limits. So what is Tessabyte? Tessabyte is a professional client-server application used for network throughput stress test. Tessabyte can be used to validate QoS and DSCP traffic prioritization, as well as network configurations. It supports both TCP and UDP protocols to measure key performance metrics, including throughput, latency, jitter, and packet loss. It also enables benchmark comparisons, scheduled test automation, and real-time visual metrics through an intuitive graphical user interface. It offers cross-platform support for Windows, Mac, Linux, and iOS. To download Tessabyte Throughput Test, we head over to Netmantics.com. Click on Download, then click on the download link for your operating system. After downloading and installing Tessabyte from Netmantics.com, you'll see two desktop icons, one for the server and one for the client. To begin, I'll launch Tessabyte's server application. The server app sets up a listener side of things, and it defaults to port number 32500. If you want Tessabyte to automatically start after a server reboot, you can always enable it through the Services app and set it to automatic. Next, I'll switch over to the client machine and launch Tessabyte Client. When you open up Tessabyte Client application, you'll see the main dashboard. The top pane displays a real-time performance chart. The middle pane shows detailed test results, and the bottom pane allows you to configure your network test. The metric drop-down list allows you to select which data subset to display: throughput, UDP packet loss, round trip time, or jitter. The units drop-down list can be used to change measurement units from gigabits, megabits, kilobits, gigabyte, megabyte, and kilobytes. The action group buttons below allows you to quickly save an image of the chart. You can also copy and paste the chart into a report document, and the last button is used to clear the chart above. On the Reports page, you can generate a report containing measurements for the host. On the Schedule page, you can perform automated throughput tests to run as a scheduled task. On the Settings page, you can configure and customize options for the application behavior. For this demonstration, I'll run a PC-to-server network stress test to establish our baseline throughput. I'll enter our server IP address and then click on the Connect button. Once it starts, the network stress test will continuously run until I click on the Disconnect button. As shown in this chart, we are achieving TCP upload speeds of 940 megabits and download speeds of 930 megabits. For UDP, we are able to achieve upload speeds of 862 megabits and download speeds of 851 megabits with no packet loss. Next, I'll save these results by navigating to the Report tab and selecting Save As. I'll name the file PC1 Baseline. Establishing this initial baseline allows us to evaluate the impact of future network changes, such as PC hardware and software changes, driver updates, and configurations. For this next demonstration, I will conduct a throughput load test from the LAN to WAN interface of our firewall to evaluate traffic processing performance with security features turned on. I'll enter the destination WAN server IP, set transport protocol to TCP, and initiate the connection by clicking on the Connect button. As shown, the firewall sustains near line rate throughput, holding between 850 to 880 megabits per second for both upload and download traffic while actively running intrusion detection systems. To preserve these metrics, I'll navigate to the Report tab Select the corresponding WAN IP and save the file as Firewall baseline. This baseline establishes our control benchmark against which we can quantify the performance impact of future security and configuration changes. For our final demonstration, we will validate that our WAN bandwidth shaping policies are actively enforcing traffic shaping controls at the firewall. I've configured an ingress and egress throughput limit of 250 megabits on the WAN interface. Now we'll initiate a traffic stream from the LAN host to the WAN server IP to measure performance. I'll enter the target server IP, set the transport protocol to TCP, and establish a test session. As demonstrated, both upstream and downstream TCP throughput are constrained at 250 megabits per second, confirming that the network firewall is successfully enforcing our rate-limiting rules. Using Tessabyte Throughput Test, you can efficiently identify and diagnose potential performance bottlenecks along the network path. Alright, I want to thank you for watching this video. Take care, see you in the next one.